This podcast is brought to you by the National Animal Nutrition Program, sponsored by USDA Natural Resources Conservation Service.
Hello, everyone, and welcome to the podcast. Today, we're going to dive into a topic that's absolutely fundamental to ruminant nutrition, but sometimes gets a little overshadowed by things like energy and protein. We're talking about fiber.
That's right, Avery. It's the foundation of the diet for cattle, sheep, and goats. And understanding the basics can really help producers make better decisions, whether it's about grazing management or ration formulation.
Exactly. So let's start at the very beginning. When we say fiber, what are we actually talking about in a nutritional sense?
Well, at its core, fiber is made up of structural carbohydrates. Think of it as the skeleton of the plant. It's what gives a plant its shape and rigidity. It's found in the cell walls.
Okay, the skeleton. I like that. So it's not like the starches and sugars, which are more for energy storage.
Precisely. The main components we talk about are cellulose, hemicellulose, and lignin. Now, the magic of the ruminant is that the microbes in their rumen can break down cellulose and hemicellulose for energy. Mammals can't do that on their own. Lignin, on the other hand, is essentially indigestible. Think of it as the rebar in the concrete. It makes the plant really tough and rigid, especially as it matures.
Right, so more lignin means less digestible material. Now, when folks get a forage analysis back, they see these acronyms, NDF and ADF. Let's tackle NDF first. What is neutral detergent fiber telling us?
NDF, or neutral detergent fiber, is a great place to start. It basically represents the entire plant cell wall. That's the cellulose, hemicellulose, and lignin all bundled together. The most important thing to remember about NDF is that it's related to intake.
To intake, so how much the animal can eat.
Yes, NDF is the primary component that gives a feed its bulk. Think of the rumen like a big fermentation vat. It can only hold so much. High NDF forages are very bulky and are digested slowly. So the higher the NDF percentage, the quicker the rumen fills up and the less total dry matter an animal can consume in a day.
That makes perfect sense. So if you have really mature hay with a high NDF, a cow just can't physically eat enough of it in a day to meet her energy needs, especially if she's, say, in peak lactation.
You've got it. NDF is our best indicator of gut fill and potential dry matter intake. Now, that brings us to the other common term, ADF.
Right, acid detergent fiber. If NDF is about intake, ADF is our indicator for digestibility, correct?
Exactly. The ADF fraction contains the least digestible parts of the plant cell wall, primarily cellulose and that indigestible lignin we mentioned. So as the ADF percentage in a forage goes up, its digestibility goes down. You can have two hay samples with the same NDF, meaning they have a similar fill effect. But if one has a much higher ADF, it means the animal will extract less energy from it because a larger portion of that fiber is indigestible.
Okay, let me try to summarize that. NDF is the whole cell wall, and it predicts how much they can eat. ADF is the toughest part of the cell wall, and it predicts how much energy they can get from what they ate.
That's a fantastic way to put it. Simple and accurate.
But there's another layer to this, isn't there? It's not just about the chemical composition. It's also about the physical form of the fiber. I'm talking about effective fiber.
Yes, this is such a critical concept, especially as we incorporate more co-product feeds or manage high-production diets. Effective fiber, or sometimes you'll see it as PENDF, refers to the ability of the fiber to stimulate chewing and rumination, and that all comes down to particle size.
The scratch factor, I've heard people call it.
That's the one. Ruminants need long particles of fiber to stimulate the rumen wall. This action promotes mixing of the rumen contents, but more importantly, it makes the cow chew her cud.
And chewing cud produces saliva.
Lots of it, and saliva is rich in natural buffers like bicarbonates that help keep the rumen pH in a healthy range. Without that effective fiber, without that cud chewing, the rumen can become too acidic, which hurts the fiber-digesting microbes and can lead to a whole host of health problems.
So a feed like, say, soybean hulls might have a high fiber content on a lab analysis, but because it's finely ground, it doesn't have much effective fiber.
That's the perfect example. Soybean hulls are very digestible, but they provide almost no scratch factor. They pass through the rumen quickly and don't stimulate rumination. So while they are a good source of digestible fiber, they can't be the only source of roughage. The animal still needs long stem hay or silage to keep that rumen mat healthy and stimulate cud chewing.
So chopping your hay or silage too finely could also reduce its effectiveness.
Absolutely. Particle size is key. You want it short enough for the animal to eat easily and for it to mix well in a TMR, but long enough to provide that crucial scratch factor.
This is making so much sense. To help solidify this, could you walk us through a real-world example? How does something like forage maturity play into these NDF and ADF values?
Of course. Let's take a common example, alfalfa. When alfalfa is young and vegetative, in what we'd call the pre-bud stage, it's very leafy and has fine stems. At this point, its NDF might be in the low 30s and its ADF in the low to mid-20s. It's highly palatable, highly digestible, and animals can eat a lot of it. Now, let's let that same alfalfa plant mature to the full bloom stage. To support its own weight and flower production, the plant lays down a lot more structural fiber. Its stems become thicker and more rigid. If you test it now, the NDF could jump into the mid-40s or even 50s, and the ADF could be in the high 30s. That's a massive change. The cow can't eat as much due to the higher NDF, and what she does eat is less digestible because of the higher ADF, meaning she gets a lot less energy out of it.
That alfalfa example really drives the point home. So, thinking about practical applications, what happens when producers face a forage shortage, like during a drought? Are there options beyond just buying expensive hay?
That's an excellent and very practical question, Avery. During a drought, this is where understanding fiber really pays off. When good hay is scarce, you can use alternative, highly digestible fiber sources like soy hulls or beet pulp. These provide energy, but they lack the scratch factor we talked about. So the strategy is to use them to supplement a smaller amount of lower quality, long stem forage. For instance, you could use corn stalks to provide that necessary effective fiber for rumen health, while the beet pulp provides the digestible energy. It's about combining resources to meet both the physical and nutritional needs of the animal.
That makes perfect sense. It's about being flexible while respecting the fundamentals of rumen function. This has been great, Zia. Let's do a quick recap for everyone listening.
NDF, or neutral detergent fiber, tells us about the total cell wall and is the best predictor of how much an animal can consume. Higher NDF equals lower intake.
Right.
ADF, or acid detergent fiber, tells us about the least digestible parts of the plant. Higher ADF equals lower digestibility. And finally, effective fiber reminds us that particle size is crucial. We need long enough fibers to promote cud chewing, saliva production, and overall rumen health.
That covers it perfectly. Understanding these three concepts is a huge step toward building better, healthier, and more productive diets for our ruminant animals. It's all about keeping that rumen healthy. Well, that's all the time we have for today. Zia, thanks so much for sharing your expertise.
My pleasure, Avery. It was a great chat.
To our listeners, thanks for joining us. This podcast was generated by Wondercraft and moderated by NAMP.